Hi everyone. Today we're going to continue learning about the unit circle. More specifically, we're going to find the 16 coordinates around the outside of the unit circle and how they relate to the sine and the cosine functions. So this is the radius. Unit circle has a radius of 1, and the center is at 0, 0. 0 degrees is going to be over here. We're going to start labeling the triangles and then labeling the unit circle. So what we have to remember is the sine function is the height. So the y coordinates are the sine function. The x coordinates are the cosine function. And the tangent function we're going to worry about later because it's a mixture of sine and cosine. So let's look at 30 degrees. So 30 degrees, if we start at 0, go counterclockwise 30 degrees, we wind up here. Now we have to think about what other triangles on the unit circle have the same height, have the same ending point at this height. So if I go over across the y-axis, I see this has the same height. And if I go from 30 degrees, I go below the x-axis, this has the same height except it's downward, and same thing in the third quadrant. So there are 4 angles that have the same height. They may be positive heights or negative heights, but they have the same magnitude. So 30 degrees, 150 degrees, 210 degrees, and 330 degrees are either 30 degrees above or below a horizontal line. So they're 30 degrees above 0, or 30 degrees below 360, or 30 degrees above or below 180. Now, we're going to take this idea and apply it with special right triangles. So we learned first semester about special right triangles, and these lengths, 1/2, square root of 3 over 2, and square root of 2 over 2, are going to be the cosines and sines of every special right angle that we have. So looking here, this 30-degree triangle is really a 30, 60, 90 right triangle. So if I transpose the triangle onto this circle, I get that the base is square root of 3 over 2, and the height is 1/2. So the coordinate points, the x was square root of 3 over 2, and the height was 1/2. Now we remember that the sine is the height, which is 1/2. So the sine of 30 degrees is 1/2. It matches the y coordinate. And same thing with the x. Now what we're going to do with that is we're going to look at 150 degrees and 210 degrees and 330 degrees and realize the only thing that's going to change is the sign, whether it's a positive or a negative. So looking in the second quadrant, the 150-degree angle, we saw that it has the same height. So the sine of 30 and the sine of 150 degrees are both 1/2. They both have the same height. And the only thing that's different about their x-coordinates or their cosines is that one goes to the right, so it's positive, and one goes to the left, so it's negative. So the cosine of 30 is positive square root of 3 over 2, and the cosine of 150 degrees is negative square root of 3 over 2. Now we can keep extending these right triangles to find all the angles in the third and the fourth quadrants. So if I wanted to go to 210 degrees, if you look, both the x and the y are negative, but they have the same magnitude. So it still has the height of 1/2, it just goes down 1/2. So the sine of 210 degrees is negative 1/2. And the cosine of 210 degrees is negative square root of 3 over 2. And same thing with 330. So every angle has 3 other angles, 4 in total, that have matching lengths, matching sines and cosines, and the only thing you have to do is change the sign. Now go practice filling in your unit circle, and then refer to the diagram as you need to check your answers.